called TAPS, which is an acronym TAPPS, Think Aloud Paired Problem Solving. And so what this does is it does provide kind of that administrative assistant structure in a sense to problem solving and the process of problem solving, but it also, more importantly, kind of introduces the idea of metacognition into a student's development, which is, does anyone know what metacognition is? Yeah.
It's thinking about how you think.
Perfect. Yeah. Just thinking about your thinking, kind of like a meta-analysis of some studies of cancer or whatever. They look at all the different studies that dealt with cancer and they try to find a big common trend or thread throughout and see if they can extract an even more powerful result. Same thing about metacognition. You're kind of thinking about how you're processing things, and that awareness gives you power to think more deeply about that process. So we're going to try it because it's in order for you to be able to do it in your class, it's helpful to kind of see this first and see how it's structured, because there is a big component of structure to it. So Andrea's going to be working on the problem, but she's going to be very explicit and overt with what she's saying. And if I don't hear her saying something about how she's processing working on this problem, I'm going to ask her questions. That's my only role, is just to ask questions. I'm not going to say, oh no, you're doing that wrong, or no, why don't you try this? No, I'm going to be like the best tutor on the planet, where all I do is I say, oh, what are you thinking about right there? Or, why did you choose that? And that's if she's not talking about it herself. I could have the easiest job in the world for 2 minutes as she's working on this, and just watch if she keeps talking. So, okay, so is that clear what the two roles? She's going to be just working on this problem. Here.
Okay, thank you.
And then just talking it out, how she's working on the problem. And then I'm going to be just sitting here waiting for her to, if she's quiet, I might prompt something for her to keep going. We're just going to do this for 2 minutes. And while I'm doing that, I'm thinking about the strategies that she's using. So she's going to be working on this, and I'm kind of mentally recording, wow, okay, that's how she started, that's what process she's going through, because if this is done with 2 students, I might not have ever seen some of the strategies she's using. And it might be a wide awakening, like, oh my gosh, this is the most wonderful thing since sliced bread, is this particular strategy I'm seeing how she's engaging in this problem. So that's my role. Besides just prompting, I'm not, you can make a robot do that. But it's my role to learn about how she's processing this problem. Okay, that was a huge intro, but are we kind of clear about the
I like
roles?
it because when I put my kids in partner work, the dominant one will just solve it.
Yeah.
But they don't know the process that it took to get there.
Right.
Yeah, that's
Right.
that's neat.
Right, and so you by doing it, and then we swap, and then I'll do and I might include some of the new strategies, but I might have my own. So then when I do the swap, and then she is privy to new strategies coming out that I shared. And then it's a very kind of, that's kind of a social component, where I'm sharing my strategies, she's sharing her strategies, and we get to learn about working on the problems. Okay, and it's very strategy, it's not like, oh, okay, 3, that's the answer to the problem. Yay! It's not about the answer to the problem, it's about how I go about and that process that I engage in.
Okay, you're choosing between 2 different window washing companies. The first charge is $5 per window, the second charge is a base fee of $40 plus $3 per window. How many windows would you need to have a second company to be preferable? How many windows would you need to have for the second company to be preferable? Okay, so I'm dealing with 2 window companies, and I'm looking, and I'm very visual, so I just rock things out. And so I'm looking at how much they charge for every window that they get, that I want cleaned. So the first company charges $5, I would say per window, and I'm going to use W to let it equal the number of windows. And the second company charges a base fee of $40, so that's a fixed fee. And again, I've always learned the per window, at least like this way, I can tell my kids that normally is going to be the variable, but, excuse me, 40, that's base fee plus the $3 per window. Okay, and then so now, this is how much they charge every time they clean a window, and so how many windows do you need to have the second company, so this is, I'm gonna call this second company, to be preferable. So I need this to be less, I would imagine, than that one. Because I want this to be preferable, I would imagine it would be, pay for less, so I'm gonna just solve for W in this case. I kind of want to do it against some checkpoint too. Oh, sorry. So I'm just solving, I'm gonna get the variable all by itself, and I think W has to be greater than 20 for this one to be less, and so I guess that the last thing that I would do is I try to prove that that would be a true statement, to see if that works out. So if I pick any W.
Okay. So, thank you. That was it. That was 2 minutes. And so, and again, the point is not to come to a conclusion, to solve the problem necessarily, although if you go through, you know, if they do go through the whole way. No, wait.
Oh, the reverse gets to
Because I have
okay.
to, well, not just that, but what the next step in this process is I get to explain to her what I interpreted her strategies were.
Okay.
So for 1 minute, I'm going to put this down to 1 minute, and then for 1 minute, I'm going to talk about what strategies she employed. So, because sometimes you're using strategies too as a student that you're not even aware of. So again, to promote metacognition instead of just cognition, we point out these strategies explicitly. Okay? So for 1 minute. So,
Okay.
So the first thing that I really saw that you did was to read through the whole problem first.
Yes.
And then go back and kind of read it again and more dissect it. So you're trying to get maybe a big picture or something, but you read through the whole problem. The next thing that I saw you do was kind of stop and do a little bit of this underlining of things that you were kind of important for. Yeah, yes, that was one thing. I'm sorry, that wasn't the next thing, but that was one thing I noticed. You talked about what kind of pre-existing strategies you had by like saying the per window, that's oftentimes what the variable is going to be. So that's interesting, and we could maybe kind of see how that works in different problems maybe. And then you started drawing some diagrams, which seemed to help you kind of understand how to kind of set up the problem. Okay, so there we are, and that you know, I'm cutting it off on, you know, kind of a little arbitrarily, but in a classroom you can have, you know, a little bit more time than the 2 minutes to actually do the problem. You could have more time than the 1 minute to respond, but typically you kind of keep it very rigid so that it kind of moves along and you kind of get that idea sharing going. Okay, so are we ready to try? Thank you. Now you can.
Okay, thank you.
So are we ready to try this with pairs? Okay, so I have the problem.
You know, if I may interject as you set things up as well, a lot of times you're going to notice that as you make your way through the room, there's certain people that aren't going to be able to create an equation or an inequality right away to solve. They're going to start maybe going through let me just try, how much does one window cost? How much does two windows cost? Maybe go through just a checkway, or they're gonna, and that's fine. It's just important that the other person is pretty silent and not guiding them as to what they should be doing, but asking those questions about, so what do you think if you do this? Or are you sure? And you could also do that if you realize, or the other student notices that the person's making a mistake and going down the wrong road, they may say, are you sure about this? And just to point that out.
So thank you, because that's really important. So this is also in, if you have the 520 binder, this is page 11. So if that's more helpful, but if you have a 410 binder, this hasn't worked its way quite into 410, which shows the dynamic nature of the course development and the fact that we're trying to, you know, put things in and everything gets iterated into it. But it is a very powerful strategy, and all of this is based on the notion of reading apprenticeship, if you've heard of that. So, and that's kind of a, in some ways, it's kind of a poor label because it's, it doesn't just apply to word problems. It's not just about reading. It's more about this kind of metacognitive process that you engage in. So you can use a graph, and you could read a graph. It's kind of any text-based item that you're trying to get information from. This is page 11, and so if we can get maybe the, oh, do we have pairs again? Perfect. Perfect. So if we could have the left-hand side actually do the problem as stated. Is that fair? So everyone on this side and on this side will be the partner that's actually engaging in it. I will keep timing it just to give you a flavor for what this is. And remember, you're supposed to be talking continuously about how you do it. It's a different problem. Now, it's probably not, I mean, a 520 student is going to struggle with this problem more than you will, hopefully. But you're still going through the same process and you're still using strategies. And sometimes it's extremely helpful to model your process in front of the class. Because, you know, with that, it's like, oh, just like she did. If Andrea was, it's Andrea, right?
Yes.
Yeah, if Andrea did what she did in front of the class, the students would go, oh, wow, maybe I should read through it first. That might help. Hey, maybe I should identify maybe what the variable is. Maybe I should write it down. Maybe I should draw a picture. Maybe I should do these things that mathematicians do as they encounter a problem, even if it's one that they've, you know how to solve, and they could probably do it by chunking things together in a more efficient way. If you extrapolate all that and kind of show them explicitly how you would go through it if you didn't know how to chunk it out, then it might be helpful for them. So I'm having the left side do it for 2 minutes. Does everyone have either up there or you found it in your binder? Okay, so now the person over here now has a minute to say what the strategy was. Okay, so I'm going to time it just so you have 1 minute, and tell the first person what that strategy was that they used. Or strategies, plural. Okay, so we're going to swap roles. I'm going to swap the problem. At the very end, I'm going to call for some general strategies. So keep that, you went through that exchange. Just keep those in mind as we move to the next pair, because we're going to call out. Because that's what you would possibly do in a class, is make those strategies not pairwise apparent, but you'd make it group-wise or class-wise apparent. Because if someone in the way back might have the most beautiful strategy in the world that worked great, and then someone in the front, you want to make sure that they're privy to that strategy. So you might kind of call it together. So I'm going to do that at the end, but we're just going to go to the second problem now, which means that the people on the right are going to solve this problem, and the people on the left are going to record strategies. Okay? So let me get the timer ready. And you ready to go? So it's either up here, it's just on the back page, page 12, if you have the 520 binder. If that's easier for you to work with. Okay, ready? Okay, go. That's great. Okay, so the next thing is for the people on the left, if I get this right, to say what strategies they used. Just because people on the right just to solve the problem, or tried to attempt to solve the problem, correct? So let me give you 1 minute to do that. Tell them what strategies they used. Go ahead.
Like you said,
Okay, so do you want to go ahead and report, is there any strategy, especially like a new novel strategy? We've probably seen them all, we've probably used them all, but a new novel strategy that you weren't expecting your partner to use that was kind of cool? No pressure. What about just some of the more common strategies? Yeah?
Well, one of the things that I think sometimes we do disservice to our students is we encourage the students to talk and think aloud. So it not only helps themselves remember, but also cues in other students. But then when we give a lot of assessments, it's silence. And so they can't even hear their own thoughts sometimes, because there's a difference between thinking internally versus thinking aloud. And I think sometimes we do disservice by not allowing that element in some of the assessments that we do.
Okay, so 10:30, keep that in mind. We're talking about testing and assessment later today, so absolutely. And strategies, any other strategies that? None?
Even the common one?
Sure, yeah, I was saying just what,
Set up a proportion.
is that okay? Okay, so it's like a structural mathematical content strategy, okay. Any others?
My partner, he kind of, explains to me verbally first, and he kind of think out things out loud, and then he put it on, wrote it down. And so, I think many of us instructors may be guilty of, sometimes skipping the explanation and then jump right away to the mathematical part. But here, he actually explained to me verbally first how to come up, with the answer without even involving the algebra. He just, say, oh, we increase from 3 to 12, we increase by a factor of 4 in terms of credits, therefore the amount of time should be increased by a factor of 4 too. So,
Yeah. No, thank you, because that's when I was talking about chunking, we've all done that because we're experts in the field. So we can chunk these things together. For us, it's a very easy cognitive process to form an equation. Not always, but for some of these problems, it's almost like we see what the equation is right away. And for a lot of students, they don't see that translation. That translation, sometimes needs an introduction to how that would translate.